There's a couple that has requested we test this baby for any diseases because they're both healthy carriers of novism.
Get me a restriction fragment length polymorphism of chromosome 7, gene N.
Why not just use a single nucleotide polymorphism?
Because we need to use the restriction length fragment polymorphism to target the general area so we can find the specific loci and use single nucleotide polymorphism to determine which nucleotides are different so we can determine which alleles are present.
Oh, that's right, because you use restriction fragment length polymorphism to isolate a specific region of DNA between two restriction sites that we can separate using restriction enzymes. After that, we can use electrophoresis to then break down the region of DNA into smaller fragments. Then we can determine if there's an unusual disruption in the pattern and size of the fragments and resulting target DNA to indicate if there's a presence of a recessive allele.
How long do you believe the testing will take?
About 30 to 45 minutes.
Page you when you get the results.
Okay, see you. We have found a disruption of the pattern compared to the parent in the DNA banding.
Now let's isolate the specific sequence of nucleotides that are disrupting the pattern. We'll do this by using single nucleotide polymorphism. We can insert molecular beacons in the DNA sample via microarray. This will let us know the sequence of nucleotides because the beacons will light up due to fluorophore molecules within the molecular beacon. Using the nucleotide sequence of the target region, we can determine which nucleotides differ from the parents, letting us know the sequence of nucleotides expresses a dominant or recessive allele. This will tell us if we need to turn the gene off, so we can determine the disease if needed.
Okay, the test will take about 25 minutes.
What were the results?
Through the sequence of nucleotides, we found that the baby expresses two recessive alleles. Is there any way to stop the disease?
Well, I don't recall anything we could do. After a couple of days to think about it, I recalled that we can use RNA interference.
What's that?
We can take a piece of RNA and insert into the baby cell using a combination of microRNA and small interfering RNA, which will inhibit the gene expression by binding to the complementary DNA, which is responsible for novism. This allows it to turn it on or off. In this case, we can turn the gene on forever, allowing us to make the gene dominant, getting rid of the disease.
Oh, that's right. Thanks for the refresher. When are we going to insert the RNA?
Prepare to insert the RNA into the baby right now.
Okay.